are Group 7. I'm Rui Zhejiang.
I'm 中泽颂。
向应曲。
I'm Jiang Liu.
And we are now making the presentation of our final project, Project 4, which we're gathering all the tasks in the previous 3 projects. The Project 4 is a home sensor system which is used to gathering data from the surrounding environment. The main tool we used is this ESP32 CP2102 module. It is embedded with the Wi-Fi development board, which can be connected to the network and upload some data. We also used 3 sensors to collect different data from the environment. The first one is the DHT11, which is a temperature and humidity sensor. You can use it to collect the temperature and humidity data from the air. We also use is the digital light sensor made by Grove. It is used to detect the intensity of the natural light. And this is the MQ2, which is a gas sensor that can be used to detect the carbon oxider in this carbon oxider, which is a poisonous gas. About our project, our program. When you make all the programs flashed into the board, you will get into a shell, and you need to enter a password here. The password is already stored in the NVS, but you can also change it when you logged in. Here we entered 123456, which is our default password, and press enter. Now we entered the main program. Here you can type here help, and this page can tell you this page demonstrates all the command you can use in the shell and their uses. For example, show is used to show all system parameters, which are stored in the NVS, and set is used to set some parameters in the NVS. For example, the username, the password, or the Wi-Fi SSID, and so on. Show send, this command is used to show sensor parades, which is also stored in the NVS. And the sensor command is used to set or change some parameters about different sensors. You can change temp sensors, photo sensors, gas sensors. And if you type run, you will start the program and enter the main loop. And quint is used to exit the program. Log is used to toggle the sensor log. And now we enter run. The first task is to connect to the Wi-Fi. You can see the system is successfully connected to the Wi-Fi. And the second task is to get the UTC time and change it to local time. Here we have successfully got the local time here. It's 2018, December 6th, and this is the current time. And from now we have successfully entered the main loop, which will periodically get different data from different sensors. Here we can see there are temperature, humidity, photo, which is the intensity of the light, and the gas sensor get the gas value, which demonstrates the carbon oxidizer. And now this is what printed in the console. So let's see our board. So this is our board. You can see here. Now let's see our hardware. As you can see, in the middle is the ESP32 module, which can control all the LCD, LED, and different sensors. Totally, we used 5 LEDs, which simulates 5 different facilities in the house that can change the value of the temperature or humidifier, or make some emergency warning in our real life. This is the detail of the 4 LED, and the first row is their color, and the second row is what they simulates, and their corresponding GPIO number. The yellow one means the humidifier. It will be lit up when the humidity value gathering from the DHT11 is too low. The second one is the light one. It demonstrates the emergency warning. It will be lit up when the gas value, which means the concentration of the carbon monoxide in the air, is too high. The second one is the red LED. It simulates the air conditioner. This LED will be lit up when the temperature get from DHT11 is too high. The fourth one is the green LED. It simulates the heating furnace. It will be lit up when the temperature is too low. And the last one, the blue one, the one in the far right, it simulates the dehumidifier. It will be lit up when the humidity level is too high. And all the sensor data and the current time will be periodically printed on this LCD. As you can see, this is the LCD display. It uses an I2C module. As you can see, this is the I2C module to get connected with the ESP32 module. As you can see from the display, it will first display the current time, and then there are 4 readings. Because this screen is not that large, so we only use one letter to demonstrate demonstrate each sensor on the screen. T means temperature, H means humidity, P means photo, and G means gas. Now let's make some small tests about our system. For example, we can change the environment around the DHT11 sensor. As you can see, the humidity is now increasing sharply, reach 88%. And the LED simulates the dehumidifier is lit up, this blue one. We can also make some tests toward this photo sensor. For example, if I hold it, there will be no light around it. Now the photo value reaches 0. And when I release it, it will increase slowly. Finally, our system can also update the data gathered from all the sensors periodically to an MQTT server. And here is, as you can see, when we connect it to the Wi-Fi, the MQTT task will run periodically. You can see here, this is the notification that some data are successfully uploaded to the MQTT server. In the MQTT client, this one told us that the MQTT event is successfully connected, which means we have successfully established a connection with the server. And then there are 4 notifications that sent publish successful, which each one is corresponding to a data, which is temp data, humidity data, photo data, and gas data.